We are still into converting the degree measure of an angle to its radian measure. Example 3.6, degrees to radians. Convert the degree measure of an angle to its radian measure. Our angle has a degree measure of 120 degrees. So in this example, angle CBD. Angle CBD has a degree measure of 120 degrees. What is the radian measure of this angle? In order to get the radian measure of that angle, we will get the length of this arc, this red or purple arc. The length of that arc is the radian measure of our angle. And by the way, that arc is an arc of your unit circle. This circle here, the circle with a green curve, which is traced by a green curve, that is a unit circle. Its radius is equal to 1. Okay, so how do we obtain the radian measure of this angle? So this is how we do it. The ratio of 120 degrees to the straight angle 180 degrees. So the straight angle is this. That is 180 degrees. So the ratio of 120 degrees to 180 degrees is equal to the ratio of t to pi. Why is that? Well, this is our t. And our pi is the length of the entire curve of your semicircle. That's 1/2 the circumference of your circle, which is pi. This is a result of the properties of proportions. Okay? The radian measure of your angle is directly proportional to the degree measure of your angle. So we shall solve for t. So that's it. The length of our arc, t, which is the radian measure of our angle CBA, is equal to 2 pi over 3 radians. Convert the degree measure to radian measure. What if our angle has a measure of 225 degrees? So where is that? So 225 degrees, okay, so that is 180 degrees plus 45 degrees. So that will fall in your third quadrant. So this is our angle with a degree measure of 225 degrees. The radian measure of this angle is the length of our arc t. What is the length of that arc? Again, we will set up our equation. And this one uses the properties of direct proportions. So the ratio of 225 degrees to 180 degrees is equal to the ratio of our arc, t, to pi. Solve for t. So the radian measure of an angle whose degree measure is 225 degrees is 5 pi over 4 radians. Now we are given an angle whose measure or whose angle measure is given in radians. We shall find its equivalent measure in degrees. So in terms of degree measure, what is the degree measure of an angle whose radian measure is -7 pi over 6? So again, our understanding is if an angle is negative, we are rotating the terminal side clockwise. we know the length of the arc T. It is equal to negative 7 pi over 6. So this red curve here, this arc, that is the radian measure of our angle, and it is equal to negative 7 pi over 6. So we do not know now the degree measure of that angle. So how do we solve for D? D is the degree measure. So again, we set up our equation. The ratio of 7 pi over 6 to pi. Pi is the straight angle. Pi is this. Pi is the length of your arc of the semicircle, or 1/2 of your circle. This one is equal to, we don't know D. Okay, it is equal to the ratio of D to the straight angle, which is 180 degrees. Let us solve for D. Okay, so this one is equal to negative 7 pi over 6 pi. So in terms of degrees, an angle whose radian measure is negative 7 pi over 6 is the same as an angle whose degree measure is negative 210 degrees. How about negative 5 pi over 4? So negative 5 pi over 4 is the same as negative 4 pi over 4 plus negative pi over 4. So this is an angle whose direction of rotation is clockwise. So this one is pi. And then we will add negative pi over 4. So this one is negative pi over 4. Okay, so what is that in degree measure? Again, we set up our equation. The ratio of negative 5 pi over 4 to pi, the straight angle, is equal to D. We don't know D. D is the degree measure of our angle. It is equal to the ratio of D to 180 degrees. Let us solve for D. So this one is equal to 5 pi over 4 pi. In terms of degrees, this angle has a degree measure of negative 225 degrees.